Okay, so let's work on more tree problems. Today we're going to look at inverting a binary tree. So yeah, I think easier to explain with the example over here. So for this example, basically it's like you swap in a way where it's like you're looking at a mirror. So if there's a mirror here, you look at 2, right? The mirror version of it. From the distance from the middle would be 7, and then for 1 it would be 9, and 3 would be 6. So yep, just swap it, and yeah, that's the idea of this problem. And there are 2 main ways of solving this. The first one is via recursion. The second one is iterative. So with the recursive approach, you go all the way down. So you go depth first, and then once you reach a base case, then you start to go back up again, node by node. You visit every node one time. So this will run in linear time. And yeah, if you're using a recursive approach, you have to account for the recursion stack as well. So yeah, so that would be a linear space. And okay, so let's go ahead and solve this problem then. Okay, so the big base case is, well, once we reach the end, and there's no more root over here, that's when we return nil. Otherwise we want to recursively flip the nodes. So for the left, right, then you want the left node to equals to the right node, and you also want the right node to equal to the left node, and just return the root. Equals. Okay, let's maybe just go through an example of how this one works. Okay, the tree visualizer. Okay, so we have a root. The first one would be 4. Pass this, and we recursively call on the left. So it's like 2, right? And the left of 2 would be 1. And then be new, so we return new. Okay, and then then we go to the right. Over here is new, so we return new. Okay, so we basically swap the 2 new value over here. Which is just new and new, makes no difference to the value output. And then we return the root, which it is 1. Okay, so 1. Now we're back here. So the value passed back from the left is 1, and then we go to the right. The right, we call on this, and we pass on the left and the right again. Right, it's been new, swap the new. Okay, so you swap it over here, and then you turn the root. The root is 3, so looking from 2, right, your right is 3, and then you swap 1 with 3. Right, so again, right, left is 1, right is 3. You swap these values, then it becomes basically over here, but not over here yet. It's just still over here on the side. And if there's a way to visualize this, keep track of the visualization. Maybe I should just draw it out just for easier visualization. Okay. 4. Yeah, so now we are here, 3 and 1. Okay, and all right, so we have swapped this. Okay, here, and we return the root, which would be 2. Okay, and then we go back here. Okay, so just like imagine, right now our for has a, so if our root is 4, which we have gone all the way back up after we've done our swaps, now our left is 2, and now we want to do the swapping on the right. So we go all the way, we go to the right first, right, and then we call the invert tree method, which would then lead us to go through this process again. So we invert the 6, of course 6 you already know is swap the nils, and then you go call on the right 9 swap the nils, and then both of them returns the root, so still 6 and 9, and then now you're at 7, so 7 you swap the 2, then it becomes 9 and 6. Okay, so after you've done that, you return the root. So alright, now we got 7. Okay, now you swap these two, right? You swap it, so then it becomes, say 7, 2, but of course these values also follow them. Okay, alright, yeah, so I hope this visualization helps. So you input, and then you get a resulting output of such. So this is the recursive way of approaching this problem. I think it's definitely much easier if you can visualize it. Yeah, the idea is to always visualize it. Think about it. Like how I like to do it is just start from, you're doing recursion, so you're always going that first. So yeah, just go all the way to as far as you can go, and then think, what you do over here, and then just slowly, backtrack. And definitely helps if you have a paper and pen if you want, or you can also do what I did right here, just draw it with your keyboard. And yeah, so that's one way of going about it. Another way of going about this is to use a queue. Yeah, so this is the iterative approach. So let's give this a crack. All right, var queue is here. So while the queue isn't empty, you wanna pop the queue. I just wanna remove the first element, and you wanna keep track of the left and the right child. Okay, left, right. Okay. Now you wanna basically like swap them. Goes to right. Right, it goes to the left. And you wanna append the next row of elements from the root, and then you continue the process of swapping. Okay. In the end, you just return the root. This should do it. Okay. Okay, and just for fun, something you can do is this. Map. Let's give this one a try. Okay. So the syntax is correct. Okay, this works too. Yeah, it's just a more thrifty way of doing things. Less line of code. If you want to do it, I mean, it's good to know, I guess. So there you have it, inverting a binary tree.